Good morning, advanced algebra students. I hope you're doing super well. I'm looking forward to doing another lesson with you. We are taking a detour into the Algebra 1 Chapter 4 section of our textbook because I want to review how you can solve systems. So we've already talked about solving systems by graphing, and today we're going to learn about solving systems by substitution. Now, we are essentially trying to get the same answer, but just the method is different. So remember, when we are solving a system, what it really means is we're looking at two lines and asking ourselves, where do those two lines touch? So typically, two lines are going to cross at one point, and so there would be an x comma y solution. But sometimes you're going to have two lines that are the same, in which case they're going to touch everywhere. So there are infinite number of solutions. And then other times you're going to have two lines that are parallel. So they're never going to touch. And so there is going to be no solution. And you can get this answer either by graphing, substitution, or elimination. At the top of your paper, you should just have 4.2, solving systems by substitution. And then don't forget to zoom in and pause as you need to. So what I'm going to do is just a very straightforward example. We'll call this example number 1. Our two lines are y equals 6x plus 7 and 3x minus 8y equals 4. So those are the equations of two lines, and I'm wanting to know where do they touch, if at all. So if this step had not yet been done for us, it is important as step 1 of substitution is that you isolate one of the variables. It can be x or y, it doesn't matter. In this case, y has been isolated. So we know that y is equivalent to 6x plus 7. And because of that, we can substitute it in to our second equation where there is a y. Now it's super important when we do this that we use parentheses. So we're going to rewrite our second equation as 3x minus 8 times parentheses 6x plus 7 and parentheses equals 4. So since y is equivalent to 6x plus 7, we are plugging in 6x plus 7 where y used to be. Now we're going to distribute, so we're going to have 3x minus 48x minus 56 equals 4. And then we're going to combine like terms and get negative 45x. And then we're going to add 56 and get equals 60. We divide both sides by negative 45. And then we want to simplify our fraction. We have 60 over negative 45. 15 goes into both of those numbers, so I'm going to divide top and bottom by 15. And I'm going to get negative 4 over 3. So that is my x coordinate. Now, we're not done because remember our solution is the point in space where these two lines touch. So this is telling me the x coordinate of that point is negative 4/3. To find the y coordinate, I go back up here where it says y equals 6x plus 7, and I write 6 times negative 4/3 plus 7. Now, ideally you're getting more comfortable with cross canceling. There is a 6 on the top and a 3 on the bottom. 6 divided by 3 is 2. So this becomes negative 8 plus 7, which is negative 1. So I know the ordered pair is negative 4/3 comma negative 1. That is the point in space where the two lines cross. Now let's do another very straightforward example here. This will be example number 2. Y equals 3x plus 1, and then 6x minus 2y equals negative 2. All right, y is equivalent to 3x plus 1, so I'm going to put that inside my second equation in parentheses and write 6x minus 2 parentheses 3x plus 1 in parentheses equals negative 2. Or 6x minus 2 equals negative 2. when I subtract the 6x, I get negative 2 equals negative 2. So what kind of a solution is that? If I do everything correctly and I get something that's always true, that means that I have infinite number of solutions. And visually, what's happening there is that our two lines were the same. So that's why they touch everywhere. All right, let's do example number 3. I'll erase this to make a little bit more room. So we'll do 2 more examples, I think, just one regular example and a word problem. Example number 3, we are going to use x plus y equals 5 and x plus y equals negative 4. Now notice in this particular case, no variable has been isolated. Again, you can isolate the x or the y. The last 2 that we did had y isolated, so let's go ahead and isolate the x this time. I'm going to subtract y from both sides on my top equation and get x equals 5 minus y. So since x is equivalent to 5 minus y, I can plug 5 minus y in for x. So I'm going to write 5 minus y plus y equals negative 4, or 5 equals negative 4. So what do you think that means? If I did everything perfectly, but I got something that I know is not true. So 5 is not equal to negative 4. So what does that mean my solution is? The solution is no solution. And it is important to use those words. You know, in our last test I had someone say no answer. This doesn't mean there isn't an answer. It means that there is no point in space that works on both lines. So there is a difference. We do have an answer to the question. Okay, let's do a word problem. So this will be our last example, example number 4. Again, I'll read this and you just need to write what I write. You don't need to read to write down the words. Nate starts a lawn mowing business. In his business, he has expenses and revenue. Nate's expenses are the cost of the lawnmower and gas. The lawnmower costs $200. The gas costs $2 per lawn. His revenue is $25 per lawn. At what point will Nate's revenue exceed his expenses? Okay, let's write down some facts here. Let's have X be the number of lawns that he's going to mow. And let's have Y be the dollar amount. And we want to come up with an expression for his revenue. And we also want to come up with an expression for his cost or his expenses. So the revenue is $25 per lawn. So this equation would be Y equals 25x. If he mows 1 lawn, he gets $25, 2 lawns, $50, etc. Now, what would be the expression or the equation to represent the cost, do you think? Y equals what? So if he gets $2 per lawn, but the lawnmower costs $200, it would be Y equals 2x plus 200. Now the question is asking, at what point will the revenue exceed the expenses? So let's set the revenue equal to the expenses, and then we'll know how many lawns he has to mow to start making money. So let's set 25x equal to 2x plus 200. We're going to subtract 2x from both sides and get 23x equals 200. Then we're going to divide both sides by 23 and get x is about 8.7. Now obviously you can't get money for mowing 7/10 of a lawn. If you have a lawn mowing business, you know, your customer's going to want you to finish the whole lawn. So he has to mow at least 9 lawns. So Nate must mow 9 lawns to make more than he spends. Awesome. Hope that was helpful, guys. Talk to you soon. Bye.